Swayam Prabha. Digital India. Educated India.
So, in the previous lecture, whatever relationship we have developed, those things, some application we will see now, solving a few problems. First, let me see the first problem. It is a moist soil sample weighing weight 346 gram. After drying at 105 degree centigrade, its weight is 240 gram. The specific gravity of the mass and of the solid is 1.86 and 2.70 respectively. Determine A, the water content, B, the void ratio, and C, the degree of saturation. This problem we will try to see the solution. First of all, we have got Ws equal to 284 grams, and Ww become 346 minus 284, so that gives you 62 grams. And then water content by definition Ww by Ws, that become your 62 by 284. So, that become 0.218. And now gamma B by gamma W is given as 1 point bulk, unit weight is given 1.86. So, gamma B, that means gamma B equal to 1.86 into 9.81. So, this value become 18.25. And we know the expression for gamma bulk in terms of water content 1 plus W into Gs into gamma W divided by 1 plus E, and this is actually your value is given 18.25. So, from here W is known, this one, Gs can be assumed 2.7, gamma W is 9.81, and then only unknown is this one, this only unknown. So, from here I can find out E equal to 0.768, and this become part A, this become part B, and part C. Actually, we have learned another relationship, S R into E equal to W into G. This is degree of saturation, this is void ratio, this is water content, this is specific gravity. So, we know this, we know this, we know this, then your degree of saturation S R, substituting all values, it comes 76.6%. So, this is the first application of whatever formula, whatever we have derived, that relationship, what is the definition, bulk unit weight bulk density, then water content, then degree of saturation, then void ratio, all definition and their values, their relationship is used in solving this problem. Now I am going to the second problem. A soil deposit is being considered as a field for a building site in its original state in the borrow pit. In its original state in the borrow pit, the void ratio is 0.95. Based on the laboratory test, the desired void ratio in its compacted state at the building site is to be no greater than 0.65. Then determine percentage decrease of volume of the deposit from its original state. So, that means at the borrow site void ratio is 0.95, and at the compacted site your void ratio is required 0.65. What is the meaning actually? That means volume will be reduced, void will be removed. So, it will be more compact. So, that you have to find out now. That calculation we will try to see. We will see that calculation is a borrow pit. One is there is a borrow pit or borrow site, and I can say another compacted site. And then in that case it is void ratio at borrow pit is given EB is equal to given 0.95, and compacted site void ratio will be 0.65. So, EC compacted site it is 0.65. Then by definition actually we know V equal to Vs into 1 plus E. It is nothing but Vs plus Vs into E. Vs into E is nothing but Vv. So, Vs plus Vv actually total void actually Vs plus Vv. So, I can write Vs into 1 plus E in this form. So, I can say Vv equal to this, and similarly then I can write Vs into 1 plus 0.95, and here I can write Vc will be equal to Vs into 1 plus Ec, and this is Eb. Now, this Vs and this Vs, these two Vs actually in two conditions, Vs will not change because of the compaction of the soil. Because of the compaction of the soil, void will be reduced, but solid volume will not change. So, that is the assumption if you make, then the two cases actually Vb and Vc. So, this is the Vs I can find out. So, reduction in volume, reduction will be equal to borrow site was more Vb minus compacted site volume become less divided by Vb. If I do this, then it become this is 1.95 Vs into 1.95 minus 1.65 divided by Vs into 1.95. So, this Vs get cancelled. So, 1.95 plus minus, this is minus 1.95 minus 0.65, 1.95 minus 0.65 by divided by 1.95. This if you do, then this gives you 0.153, and that means it is nothing but 15%. That means from a site where void ratio is 0.95, and if you take a borrow material and compact in a site with void ratio equal to 0.65, then that means how much volume actually will reduce? It will be reduced by 15%, 15.3% in fact. Okay. So, this is our second application. Next problem, suppose third problem, again similar. A soil sample taken from a borrow pit has an in situ void ratio of 1.15. The soil is to be used for a compaction project where a total of 100,000 meter cube is needed in a compacted state with the void ratio predetermined to be 0.73. Determine how much volume is to be excavated from the borrow pit. So, the compacted volume is known 100,000 meter cube, and compacted state, what is the void ratio, that is also known 0.73, and from a borrow site we will be taking the soil, and that soil is having void ratio is 1.15. So, if I want to satisfy this, if I want to do construction satisfying this condition, that means 100,000 meter cube of compacted site to be produced, how much soil I have to take from the borrow site, that is the problem we have to do. So, for this let me take this one, and you can see the again similarly borrow site and compaction site. I can divide in two parts, and here actually EB is given 1.15, and here it is given EC is given 0.73, and here actually additionally what I have got? I have got compacted volume is 100,000 meter cube. Now, this VC equal to 100,000 equal to is now this is the volume, nothing but Vs into 1 plus 0.73. So, from here I get how much solid present in that much of volume. So, Vs will get from here 57803 meter cube. So, that means 100,000 meter cube of bulk soil, we have only 57,803 meter cube of solid, and remaining actually voids. Now, I have to find out, as I have mentioned in the previous problem, that in the same soil if I use and compact, then by compaction only we are removing the voids, not reducing the solid. So, solid will be remain unchanged. If that is the condition is taken, now I can consider VB equal to Vs into 1 plus 1.15, that is the void ratio of the site. So, if I substitute this Vs here, then I will get this VB equal to 124,276 meter cube of borrow. That means, for 100,000 meter cube of compaction if I want to make, then I have to, how much I have to do? I have to bring from the borrow site 124,276 meter cube, 1,24,276 meter cube. So, obviously, when it is loose, the volume will be more. That more volume, if you put in the site and then compact, then you will get the actual volume. So, this is the third application. Now, I will go to fourth application. The soil sample in its natural state has, when fully saturated, a water content of 32.5%, and determine the void ratio, dry and total unit weights. Calculate the total weight of water required to saturate a soil mass of volume 10 meter cube. So, this is the thing, only water content is given at saturated condition. So, that means two things are given, and GS can be assumed, which is not given, most of the time it will be given, and since it is not given, I can assume as 2.70. So, only here I have got water content at saturated condition. So, saturated condition means SR equal to 1 and W equal to 32.5%. Additionally, I can assume GS equal to 2.7, and then by knowing that I have to find out the rest of the things. So, I have to calculate total weight, I have to find out the void ratio, dry and total unit weight. First void ratio, then dry and total unit weight, and then total weight of water required to saturated soil mass of 10 meter cube. So, this one we will try to find out, and you can see this. We know the relationship SR into E W into GS, and this SR value is 1. So, ultimately I get directly E equal to water content into GS. So, water content is 32.5. So, this is nothing but 0.325 into GS is 2.7. So, this become your 0.88. So, I have got E, this is 1. So, I have got E equal to 0.88. Now, I have to find out saturated weight, unit weight and dry unit weights. Gamma sat equal to GS plus SR into E by 1 plus E into gamma W. Since right from beginning it is known that SR equal to this is 1. So, GS plus E by 1 plus E, that means 2.7 plus your E is actually I have got now 0.88 divided by 1 plus 0.88 into 9.81. So, if I do this value will get 18.66 kilonewton per meter cube. Every time unit is very important, without unit these are all meaningless. Similarly, I can we have derived gamma D will be equal to gamma sat or gamma bulk divided by 1 plus W. So, we have got 18.66. So, divided by 1 plus W, that means 1 plus 0.325. So, this gives you 14.01. And next I have got dry unit weight, I have got bulk unit weight. So, to find out the third or fourth condition. So, that means if I take 1 meter cube of soil, then what is the saturated weight? That means W saturated for 1 meter cube is 18.66 kilonewton, and WS, which is nothing but 14.01. So, saturated weight is dry weight is this, that means WW, that means only water will be this minus this, and that will be equal to 4.65 kilonewton. So, weight of water in 1 meter cube of soil is 4.65 milliliter. So, 10 meter cube of soil if you take, then how much will be there? 4.65 sorry, it was so from here I can directly get multiply by 10, 4.65 into 9.81, no 10. So, this is 10, this volume this weight I can get, and if I want to find out VW, that weight, that is WW divided by gamma W, if I do I will get the volume. So, that will be actually 4.74 meter cube. So, that means these are the 4 parts are done. So, that means if I know the water content and saturation condition, then I can find out using those relationship, I can find out other important things. So, this is the application number 5, and you can see now this problem is given 3 sites actually chosen for a construction. to take the borrow material. Material for an art field was available from 3 different borrow sites. In the compacted state, the field measured 100 meter cube at a void ratio of 0.7. That means compacted, that the compacted site, your void ratio requirement is 0.7 and total volume requirement is 100,000 meter cube. The corresponding in situ void ratio and cost of material and transportation together of the material for 3 sites are given like this. So, site 1 actually void ratio, in situ void ratio is 0.8 and cost for transportation and all those together material is 200 per meter cube. Similarly, for site 2 it is void ratio was 1.7 and cost for transportation and material 180 rupees per meter cube, and site 3 void ratio was 1.2 and the cost for material and transportation was 160 rupees per meter cube. Now, we have to find out that we have 3 sites, their cost and all those things are known and conditions are known. We have to find out now which site is the most economical. Okay. So, for this let us do we know that actually construction site VC was 100,000 meter cube and your EC equal to 0.7, and then I can find out from here Vs equal to 100,000 divided by 1 plus 0.7. So, that gives you 58823.5 meter cube. That means, out of 100,000 meter cube of solid soil, compacted soil, the solid will be this much, and this amount of solid should be there in each of the sites. So, in that case, then I can calculate now V1 how much volume if I want to take from site 1, then what is the volume required from that? It should be 58823.5 into 1 plus 0.8, which is void ratio of site 1. So, this gives you 10588 meter cube. Similarly, I can get V2 will be equal to this will give you this into 1 plus 1.7, this gives you 158 and 823 meter cube, and then V3 will be equal to this into 1 plus 1.2, this gives you 129,412 meter cube. So, from different sites actually if I choose, then a different quantity will be required. So, this from site said this quantity, from second side this much quantity, so third side if I go this much quantity will be required. Now, the cost of material and transportation is given. So, I can multiply by that volume, cost 1 will be rupees, this volume multiplied by 180 no 200 actually, that is actually gives you 2117640 this much rupees. Then from site 2 this will be rupees 254,11680, and from site 3 it will be rupees 20705920. So, that means, if I select the site 1 this much cost, if I select site 2 this much cost, if I select site 3 this much is the cost. So, which one is the lowest? This is the lowest. So, we should choose site C as the borrow site, because that will be the more economical. So, this is the application or fifth application. Now, I will do one more sixth application. So, this is the problem actually. Again, 2 sites are being considered for borrow soil. The in situ unit weight of the soil of the first site is 16.2 kilonewton per meter cube, water content is 10%. On the second side, again same unit weight is 15.4 and water content is only 14%. It is more. The construction side requires 26,500 meter cube of soil in a compacted state at a unit weight of 18.75 and water content of 14%. The soil from the one side required additional water. That means where water content is less, that is the first side water is required. The cost for the borrow material was based on volume of soil removed from the respective sides. That is, the more volume would have to be removed from the site that have 15.4 kilonewton per meter cube weight than from the other one. The unit price from each site was 100 for the material and rupees 125 for transportation for the respective cubic meter. And in addition, for the material that required the additional water, that required rupees 15 per cubic meter estimated. So determine the cost of material from each side. So that means two sides. One side will be water content is less, other side is water content is slightly more, and second side whatever water content is required is there, that is the water content is required in the compacted side. There is no need to add water or remove water, but first side, since it is a 10%, but actual condition is required 14%, so you need to add some amount of water. Now from these two sides, when soil is taken and to be constructed and their respective void ratio also is given, and if I take from the site 1 or site 2, their material per cubic meter cost is given and transportation cost also given, and where water is required, that is per meter cube of soil, how much additional cost for water, that is also given. So based on that, sometime instead of that way, how much quantity of water is required and unit price of water also given, but this problem based on solid volume approximate cost of water is given. So we have to find out the volume of soil from both sides, and then you have to estimate the cost. And you can see now I can consider site 1 and now I consider site 2. Site 1 W equal to 10% and gamma bulk equal to 16.2 equal to 1 plus W by 1 plus E into GS gamma W. So this, since water content is given, I am using this formula. I am not using SR into E because I have this one, and GS can be assumed, gamma W is known. So only unknown is E. From here I can find out E value equal to 0.798, and then your site 2, again water content is given 14% and gamma B is given 15.4, which equal to 1 plus 0.14 divided by 1 plus E into 2.7 into gamma W. This gives you E equal to 0.96. And construction site we have actually water content W equal to 14% and your gamma B equal to 18.75 equal to 1 plus 0.14 into 2.7 into 9.81 divided by 1 plus E. So this gives you E equal to 0.61, and we know the volume. So constructed volume is actually 26,500, that will be equal to Vs into 1 plus 0.61. So from here I will get Vs equal to 16459.6 meter cube. So as we have discussed previous problem also, this Vs will be from here. If whatever amount of soil you take, the Vs must be this much, Vs also must be this much from this side. So if you know the Vs, now if I take soil from site 1, V1 will be Vs into 1 plus 0.798. So that become your volume, and this is 2960 29602, and here actually this V2 will become 322,322,60.8. Now I can find out the cost from site 1, that will be equal to 29602 multiplied by cost per material is 100 plus transportation 125 plus water 15, because first site water is required. So, that become the cost, if that will be 7104600 is the cost for this site. Similarly, if I go for this site, its cost will be again this side. If I take this side, the cost will be again the volume is this. So, multiplied this 32260.8 into 100 plus 125, that gives you equal to 7258680. So, this is 71 and this is 72. So, this is a big value, and so this difference. So, that means this side become your cheaper. So, that means out of whatever condition is described in these two sides, and what is the condition described in the construction site, and if I do this calculation, based on this calculation, what I am getting? I am getting the site 1 as the most economic site, because out of 2. So, this is the one preferred. Okay. So, I think I could whatever we have derived before, with these 5 problems I could show the application of them. Okay.